Okay, this is the review for the test on October 3rd, and it's sections 2.3 through 2.6. So let's start with looking at question number 1. There's a myth that toilets and sinks drain in opposite directions in the southern and northern hemispheres. However, if you were to observe sinks draining in the two hemispheres, you would see that this myth is false. Is the conclusion the result of inductive or deductive reasoning? So in this case, we know that inductive is a given fact. If we actually saw something happening, we know it to be true for a fact, then it would be inductive. If it's deductive, then we had to use logic to come up with our reasoning. So deductive is logic, inductive is like an observation or something that was proven by scientists, or I saw it happening if a scientist saw it happening. So here we have the word observe. So we saw, somebody observed, so they saw it firsthand, they witnessed it happening. So this would be inductive reasoning. So when it's an observation, we observed it, so it's inductive reasoning. Let's look at number 2. Determine if the conjuncture is valid using the law of detachment. So we know that the law of detachment, we need two things to be true in order for the conjuncture to be valid. So we need if P, then Q to be true, and if P to be true. So we need two things, 1 and 2. So in number 2, we have if the side lengths of a rectangle are 3 feet and 4 feet. So this would be our P. Then its area is 12 feet squared. So this is our Q. A rectangle has side lengths of 3 feet and 4 feet. So we see that 3 feet and 4 feet again, which we saw in the P. So this would be our P again. So we have P then Q, check, and P, check. So therefore, we can conclude that the conjuncture, the area of the rectangle is 12 feet, is valid. So remember, we just need these two things to be true, to be given to us, and then we can say that the conjuncture is valid. So now let's look at number 3. If you are tardy 3 times, this would be our P, then you must go to detention. And this is our Q. Shay is in detention. So we see the word detention again, which we saw in the Q. So this would be our Q. So now we have P then Q and Q. But we don't have our P then Q and P. So we're missing this step. So this would be invalid. So the conjuncture is invalid, because we need the P then Q and P. But this one only gives us the P then Q and Q, so it's invalid. The same thing applies for number 4. If you go on a field trip, we can say this is our P. You must have a signed permission slip. This is our Q. Zola has a signed permission slip. So we see the word permission slip again, just like we saw in Q. So this would be our Q. So we have P then Q and Q. So again, this one is invalid, because in order for it to be valid, we need P then Q and P. But in this one, we don't have it. We have P then Q and Q, so it is invalid. Now let's look at 5. Determine if the conjuncture is valid using the law of syllogism. So remember, in the law of syllogism, we need P then Q and Q then R. We need the two things in the middle to be the same. The conclusion of one has to be the same as the hypothesis of the other, and that way we can conclude that if P, then R. So if you fly from Texas to California, this will be our P. Then you travel from the Central Pacific from Central to the Pacific time zone. This one's our Q. If you travel from the Central to Pacific time zone, so we see that same phrase again, Central to Pacific time zone, like we saw in Q. So this would be Q again. Then you gain 2 hours. We haven't seen this phrase before, so this one's R. So now we have P, then Q in our first sentence, and Q, then R in our second sentence. And our conjuncture is, if you fly from Texas to California, so that's the same. We see Texas to California, just like we saw in our P. So this is our P again. Then you gain 2 hours. We see 2 hours again. So this would be our R. So in our conjuncture, we have P, then R. P, then R. So here in our given, we drew that here. So we have the two in the middle are the same. The conclusion of one is the same as the hypothesis of the other. So we can conclude that if P, then R. This is the same thing we have in our conjuncture. So when these are the same, the conjuncture is valid. So that is the law of syllogism. So let's do number 6. Again, we're going to use the law of syllogism, so we need to use this. If P then Q, and Q then R, then P then R. So the conclusion of one has to be the same as the hypothesis of the other. So if we're given, if an animal is a mammal, this will be our P. Then it has hair. This is our Q. If an animal is a dog, we haven't seen this phrase before, so this one is a new one. That's our R. Then it is a mammal. So we saw the word mammal before in our P, so this would be our P. If an animal is a dog, we see the word dog again, so that's our R. Then it has hair. So we see the word hair, which we saw in our Q, so the conjuncture is R then Q. So in the given, we have P then Q, and R then P. So we have our two sentences, which just from looking at it, we can see that the two in the middle are not the same. However, in this case, you can switch the second sentence to come first before the first one. So we can say, if an animal is a dog, then it is a mammal. If an animal is a mammal, then it has hair. So we can take this second step and move it in front, the second sentence, and move it in front of the first sentence. So therefore we would have R then P and P then R. So now we have the hypothesis, the conclusion of one. So we have the conclusion of one is the same as the hypothesis of the other. The two in the middle are the same. So we can conclude that R then Q. And that's exactly what we have in the conjuncture here. R then Q. So this would be a valid statement. So number 6 is valid. In 7, we're going to use the law of syllogism again. But in this case, we need to draw a conclusion. So before it gave us a conjuncture and we had to state whether it was valid or invalid, now we're going to use the law of syllogism to draw a conclusion. So in our given, we have, if you leave the car lights on overnight. This is our P. Then your car battery will drain. This will be our Q. So we have P, then Q. If your car battery is drained, we see that same word drain again, so we know that this one will be our Q again. Then your car might not start. This is a new phrase, so we know that this one is R. So we have if P then Q and if Q then R. The two in the middle are the same. Oops. So these two in the middle are the same. So we can conclude that if P, then R. So what did we just say our P was? If you leave the car lights on overnight. So if you leave the car lights on overnight, then R, which we said was your car might not start. So then your car might not start. So this is the conclusion that we drew using the law of syllogism. So our answer would be, if you leave the car lights on, then your car might not start. And that's the answer to 7. Now let's look at 8. Write the conditional statement and converse within each biconditional. So now we're given the biconditional and we need to write the conditional statement and the converse. We know that the conditional statement is our generic P, then Q, and the converse is the flip of the conditional, so we have Q, then P. So now let's determine what's our P and what's our Q. So two angles are congruent if and only if their measures are equal. So we know the first part is our P and the second part is our Q. So the first part meaning the phrase before the if and only if, and the second part meaning the phrase after the if and only if. So we have two angles are congruent is our P, their measures are equal is our Q. So now we can write P then Q. If, remember, conditional statement has to be in if-then form. So if two angles are congruent, then their measures are equal. So in our conditional, we have an if and a then. So if P, then Q. This is our conditional. So now we need the converse. And we said our converse is the flip. If Q, then P. So we start with Q. If their measures are equal, so if two angles, now I'm just replacing there with two angles because that's what we're talking about is the two angles. So if two angles are equal, then we would say the P, the two angles are congruent. So then the two angles are congruent. So that's our conditional and converse determined from the biconditional, which was given. So for each conditional, write the converse and biconditional statement. So this is given to us in P, then Q form. So the converse has to be the flip, if Q, then P. So we would start if x is equal to 3, so we start with the Q, then we finish with the P. 2x plus 5 is equal to 11. This is our converse. Now we need to write the biconditional statement. So in the biconditional, we just drop the then and the if, and in the middle we put if and only if. Remember, the biconditional needs an if and only if, which is abbreviated by IFF, in the middle. So we have as our biconditional 2x plus 5 is equal to 11 if and only if. So we could rewrite this as IFF. X is equal to 3. So it's our converse and our biconditional. Now let's look at 10. Write each definition as a biconditional. Remember, biconditional needs the if and only if, abbreviated as IFF. So the measure of a straight angle is 180 degrees. So we could state our biconditional as an angle is a straight angle if and only if its measure is 180 degrees. So in the biconditional, we can turn definitions into biconditionals by including if and only if. So we're talking about a straight angle and its measure, which is 180 degrees. So before the if and only if, we need the word straight angle, and after we need the 180 degrees. So an angle is a straight angle if and only if its measure is 180 degrees. Solve the equation, write a justification for each step. So we saw a question very similar to this one, just with different numbers on the quiz. You'll have a question again like this on the test, but it'll be more like a 2-column proof where it lists out each step for you on the left side, and you'll have to fill in the blanks with the justification on the right side. So let's start this one. So solve the equation, write a justification for each step. We know the first step is given because that's the equation that's given to us. Now to solve for x, we subtract 9 on both sides. So we have 2x I'll write it the long way, including the simplifying steps in it. So we subtract 9 from both sides, and this step will be the subtraction property of equality, because we are subtracting on both sides of the equal sign. So now we have 2x is equal to 13 minus 9, which is 4. And all we did here was simplify. And now to solve for x, we divide both sides by 2. So divide both sides by 2. And this would be the division property of equality. And now we just simplify again, and we get x is equal to 2. So our justification for this step is simplify. Remember, when you're doing it to both sides of the equal sign, so we divided 2 on both sides, it is division property of equality. But when we are just doing the work on one side of the equal sign just to make the equation smaller, more concise, we are simplifying. So now let's look at 12. Write a justification for each step. This is the only case where you don't start with given. You start with given when the equation itself is given, but in this case, we had to use one of our postulates to come up with this equation. So the first step would be angle addition postulate, because we know the angle addition postulate is when you add the two smaller angles that share a side and that are contained within the larger angle. So this is, for step 1, the angle addition postulate. Now in step 2, we took what was given for ABC and plugged it in for ABC. We took what was given for ABD and plugged it into ABD, and we took what was given for DBC and plugged it into DBC. So when you're plugging things in, we are using substitution. So we substituted, so the step would be substitution. Now if we're just looking at the right side of the equation, we're combining the like terms, so we're adding 3x and 6x and 5 and negative 16. So we're combining the like terms to make the equation more concise, so we are simplifying. Now in this step, to go from step 3 to step 4, we subtract 9 from both sides, 9x, so we're subtracting 9x from both sides. So this step would be subtraction, property of equality. Remember, on the test, you can abbreviate if you need to, but when dealing with subtraction or substitution, it's better to include at least the first 5 letters so I can differentiate which one you're using. So now to go from step 4 to step 5, in order to get rid of that negative sign in front of the x, we divide both sides by negative 1. So in this case, we are using the division property of equality. And that's all that we do for number 12. Now let's look at 13. I'm going to write it off to the side here. So Amy's favorite breakfast cereal has 102 calories per serving. In the equation, C is equal to 9F plus 90 relates to the grams of fat F in one serving to the calories C in one serving. How many grams of fat are in one serving of the cereal? Solve the equation for F and justify each step. So it gives us the equation C is equal to 9F plus 90. So if it gives us the equation, this step is given. It's the given equation. So now we have the cereal is 102 calories per serving. So it's talking about the calories, so we would take this and plug it into C. So when we're plugging something in, we are using substitution. So we have 102 is equal to 9F plus 90. And we got this step because of substitution. Now in order to solve for x, we need to subtract 90 from both sides. So then we get 12 is equal to 9F. And we use subtraction. So the subtraction property of equality. Now remember, it's the property of equality because we are subtracting on both sides of the equal sign. And now we divide both sides by 9 to get 12 over 9 is equal to F. And on this step, we use the division property of equality. And now we can take it one step even further and simplify, because we know that 3 goes into 12 and 9, so we can simplify this as to 4 over 3 is equal to F. And all we did was simplify one side of the equation, so our reason here would be simplify. So that is the answer for 13. Now let's look at 14. We have segment AB is congruent to segment AB. When you have the same thing is congruent to the same thing, nothing is switched around. You have AB is congruent to AB. This is reflexive property of congruence, because we have a congruent sign here, so our answer will have congruent sign. Now let's look at B. X is equal to y, so y is equal to x. So these are flipped, but we're still dealing with the same question, the same equation, just flipped. So it is symmetric. Property of equality, because we have equal signs. Now in C, we have the measure of angle 1 is equal to the measure of angle 2, and the measure of angle 2 is equal to the measure of angle 4, so the measure of angle 1 is equal to the measure of angle 4. So we have 2 and 2, the same thing, and then we just set 1 equal to 4. So in this case, we are using the transitive property. So we have the transitive property of, we're dealing with equal signs, so this will be equality. Now let's look at D. We have segment ST is congruent to segment YZ. Segment YZ is congruent to segment PR, so segment ST is congruent to segment PR. We have the two that are the same, so then we can say that this one is equal to this one, which we said right here. So just like C, this one is the transitive property. But in this case, we're dealing with congruent signs, so transitive property of congruence. So let's look at 15. Write a justification for each step. Well, we know because of the segment addition postulate that the two smaller segments add up to the whole segment. So this, the justification for step 1, is the segment addition postulate. Now we took what we know for PQ and plugged that in, took what we know for QR, plugged that in, and took what we know for PR and plugged that in. So this would be substitution. Now to get rid of this 3n, they subtracted 3n from both sides. So the step would be subtraction, property of equality, and then they added 5 to get rid of that on both sides. So this would be addition, property of equality. And then they divided 6 from both sides, so this will be the division, property of equality. Remember, it's property of equality because you're doing it to both sides of the equal sign. Let's look at 16. Fill in the blanks to complete the two-column proof. So it's given that the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees. So step 1 we know is given. Now because of the definition of supplementary angles, so we know that the definition of supplementary angles, I'll write that down here, definition of supplementary angles states that if two angles are supplementary, then they add to equal 180 degrees. We know that definitions are biconditional, so this can go either way. So if we know that two angles add to give 180 degrees, then we know that they are supplementary. So these two angles add to give you 180 degrees, so therefore we know that angle 1 and angle 3 are supplementary. Now we see here that angle 3 and angle 4 form a linear pair. So we know that angle 3 and angle 4 are supplementary because of the linear pair theorem. Now we have angle 3 is congruent to angle 3. This is the same angle, it's congruent to the same angle, so this is reflexive property of congruence. Because we're dealing with the congruent sign in the middle, so reflexive property of congruence. And now because of the congruent supplements theorem, we know that if two angles are supplements to the same angle, so two angles meaning 1 and 4 are both supplements to angle 3, because we know angle 3 is equal to angle 3, therefore they are equal to each other. So we can say that angle 1 is congruent to angle 4. We also know that this will be our last step because it's what we're trying to prove. So once we prove that, there's no more steps. So that's 16. Now let's look at 17. Last question. Write a justification for each step, given that angle 1 and angle 2 are complementary, and angle 1 is congruent to angle 3. So angle 1 and angle 2 are complementary. So we just said that this was given. Now we know that angle 1 and angle 2 are complementary, and the next step says that they add and give us 90. This is because of the definition of complementary angles. So like we said here, the definition of supplementary angles, but in this case it's complementary. If two angles add to give us 90 in this case, then they are complements. So we have two angles that are complements, then they add and give us 90. So two angles that are complements, the next step they add and give us 90. So that's the definition of complementary angles. Next step we have angle 1 is congruent to angle 3. This was given. And now we have the same thing, angle 1 and angle 3, but now it says that they're equal. So in order to go from them being congruent to them being equal, we know that this is the definition of congruent angles. So the definition of congruent angles states that if two angles are congruent, then we can say that they're equal. Since it's a definition, it's biconditional, so it works both ways. If two angles are equal, then they are congruent. So this works both ways. So in this case, it gives us two angles are congruent, and we're saying that they're equal, so this is the definition of congruent angles. Now let's look at step 5. So we got step 5 from using step 2 and step 4. So we know that angle 1 plus angle 2 is equal to 90, but we also know that angle 1 is equal to angle 3. So we can cross angle 1 out and put in angle 3 here, and we get this equation. The measure of angle 3 plus the measure of angle 2 is equal to 90. So when we cross something out and put something back in, we are substituting. So the justification for step 5 is substitution. And now we have the measure of angle 3 plus the measure of angle 2 is equal to 90. And now we're saying that they are complementary, and this is because of the definition of complementary angles. So when you're dealing with definitions, remember you can go both ways. So we said here they're complementary, and then they add to give us 90. They add to give us 90, so we can say that they're complementary for the same reason. Definition of complementary angles and definition of complementary angles. So that's a review for your test on Thursday. Make sure you study this review to prepare for your test and know how to do all the problems on it. Good luck.